Americans are making a New Year's resolution to exercise more. It's well known that regular exercise is good for your health, but a new scientific consortium is revealing fresh insights into just how profound the benefits are for the human body. William Brangham spoke recently with someone who's helping lead this research, Ewan Ashley. He's a professor of cardiovascular medicine and genetics at Stanford University and the newly named chair of its Department of Medicine. And he calls exercise the single most potent medical intervention ever known.
Ewan Ashley, so good to have you on the News Hour. You are undertaking this massive multidisciplinary study to understand how exercise changes our body in some fundamental way. But as I mentioned, don't we already know a lot of this? I mean, what is the importance of doing this much deeper dive that you're doing?
Well, we've known for maybe 70 years that exercise was among one of the most potent medical interventions known. We knew from studies in the 1950s comparing London bus drivers and London bus conductors that lived in the same environment, but the bus drivers were sitting, the conductors were standing, and the heart disease rate among the drivers was twice that of the conductors. So yes, we've known for 70 years that exercise is really, really good for you. But we have not, through that entire time, really understood how it works. So the new study was to bring together 18 different groups from across the United States to really study, to build a molecular map of exercise, to try and work out how come this intervention that's so available to all of us is the most powerful intervention known. How does it actually work?
And so you've started to publish some of your findings. When you compare exercise to these other critical things that we know are important for health, diet or sleep or things like that, where does exercise fit in? What are the sort of top-line findings of exercise's potency?
Well, one of the things that really surprised us, we're all exercise people already, so we were all convinced as to the benefits, although in this study, we also had a control group. So the first study we released was of rats that were sedentary, and then they were trained over the course of 8 weeks, aerobic training, literally on a treadmill. And then at the end of the period of time and at the end of several time points along that 8-week time period, we looked at the tissues from the rats. And the thing that we were really surprised to find was that really they turned into almost different beings. I mean, exercise was that potent. Every single tissue we looked at showed something completely different from before. It really changed the entire molecular makeup of the individual organs of the rats in a very positive direction. One example might be that multiple tissues, for example, fat tissue. Another example would be the mitochondria, that are little battery-like organelles inside each cell. When we looked at the changes with exercise, we often saw mirror image changes to the ones we see with disease. So exercise was quite literally kind of reversing in a mirror image-like way the changes that happen with disease and explaining a little bit about how exercise manages to protect from those diseases.
I mean, some of the other findings I read in your initial research is showing that exercise impacts the body in ways that we don't associate with exercise, the digestive system, the mood and mental health. How do you explain that mechanism being so widespread?
Well, I think one of the things is that exercise at the end of the day is a stress. And we don't recommend stress for anyone, certainly not work stress. But the reality is, I think that stressing our bodies with exercise in just the right amount actually prepares our bodies to deal with the stress of everyday life. One of the biggest signatures we saw was in a system that basically tends to the proteins in our cells. So it helps them come together in the right format in 3 dimensions. It stops them sticking together and aggregating. And when it's time for those proteins to be renewed, it helps. It's called the heat shock response. And this was something that we saw changed across multiple tissues, across all the tissues, as you mentioned, lung, skeletal muscle, heart, not just the ones that you might expect. We would expect perhaps skeletal muscle and heart for sure, but we were seeing changes in the kidney, in the adrenal gland, in the intestine, in the brain. And I think that begins to get at how exercise is just such a remarkable intervention, essentially helping with, for example, reducing the risk of heart disease by 50%, reducing the risk of many cancers by 50% and more, reducing the risk of back pain. People sleep better. They have better mood. They're able to breathe better. There are just so many ways in which exercise helps. And I think the key is just stressing you just enough so that your body then in recovery builds these mechanisms that help you deal with the stress of life in other ways.
And I understand there have been some interesting gender differences in your results. Can you explain a little bit about that?
Yeah, I think one of the other things we were really surprised by was just the extent of the changes. In this study, we had both male and female rats, and of course we expected to see some changes, but really the changes were profound. And we saw them both at rest before we started, but also with exercise. Some things got closer together with exercise between the sexes, some things got further apart. And this was the case particularly in adipose tissue and in skeletal muscle, where we really saw very profound differences between the two sexes. And I think what it led us to believe is that really every study from now on should be done with both sexes. This is something we've known for some time, but over the history of science, we've tended, just because science costs a lot of money, to choose one or the other. We do studies in all males or all females or both when we could, but often the numbers were smaller then, and that gave us less power for discovery. What's really clear, I think, from this study is that we really have to do both sexes in order to really work out what the differences are and be able to describe them adequately for both sexes.
I know people listening to you will, of course, be wondering, I'm sure you get this question all the time, what kind of exercise, how often does it matter, when I do it, how much I do it? What does your research indicate?
Well, this particular research with the rats doesn't answer that question, but fortunately we have lots of research to give us a good answer to that question. And although you read lots of different things as every new study comes up, the overall advice has remained the same. The first thing is any movement is better than none. So if you're in a sedentary job or you're not used to moving much, then just stand up. Standing up is a good start. If you can walk, take some walking paces, go for a walk at lunchtime, that's great as well. If you can get 30 to 45 minutes of moderate intensity exercise, that's like a brisk walk. If you can do that 5-6 times a week, that's fantastic. And of course, if you want to do more, there's added benefit. One of the things I regularly tell my patients, I'm a cardiologist, is that 1 minute of exercise buys you 5 minutes of extra life, which means you definitely have time to exercise. Because even if you exercise even a little bit higher intensity, you get 7 or 8 minutes of extra life. So you definitely have time to make in your day to exercise. It doesn't matter whether you do it in the morning, at lunchtime, in the evenings, particularly good after meals. So the evening is a fine time to take a brisk walk. But the main thing is get up, move about as much as you can.